All right, I'm going to do two straightforward examples for the Doppler effect, and then I'm actually going to do a couple more videos with more complex examples, but these are just going to be straightforward using the formula. Fire truck siren has a frequency of 1,000 hertz. Temperature outside is 10 degrees. What frequency you observe as the fire truck is driving towards you at 35 meters per second? When it passes, you continue at the same speed. What frequency you observe? So I want to know how fast is it going when it's going towards, and I want you to do away as well. First things first, we have to use this 10 degrees Celsius to find the velocity of sound and air this day. So it works out to 338 meters per second. So if the object is moving towards you, the frequency observed will be equal to the original frequency times the velocity of sound divided by the velocity of sound minus the velocity of the object. If it's moving away from you, we have the same equation, but this time, instead of it being the velocity of sound minus the velocity of the object, it's plus. In this example, then, we have 1,000 hertz as the original frequency, 338 meters per second. The velocity of the object was 35 meters per second. So I just put all that into a calculator. I get 1,116 hertz if it was moving towards me. Now when it's moving away, I get 906.2 hertz. So I'll just show the substitution of the variables here. So that is how much that frequency is shifted if the object is moving towards or away from you. Okay, one more quick one. Car engine approaches you and you observe the frequency of 112 hertz. The car is traveling at 25 meters per second. What frequency sound is the engine actually producing? Now we're going to assume it's 20 degrees out. So again, step one, I'm going to use that temperature to come up with the speed of sound in air in this example. So that's 344 meters per second. Now with that in hand, this is the observed frequency. So when I use my formula, and it's approaching you, so that means that it's the towards formula. So if you observe 112 hertz, the question is, what's the original frequency? And I'm just going to use my bed mass here, and I'm going to simplify everything on the right-hand side before I try and rearrange. And so dividing both sides by that factor of 1.078, that's the factor that represents how much the frequency was changed due to the motion. The original frequency must have been 104 hertz. So a simple example where we figure out how much the frequency is shifted, and then given a shifted frequency, what was the original frequency?